Alright, now we're going to talk about force in the direction of a line. Force in the direction of a line. This is an application of the position vectors. So in the case that we have a force of a given magnitude and the direction is given by a line that connects two given points, this is where we can use the position vectors. They come very handy for this. So let's say that we have a force here of magnitude F, and they tell us that the force is directed from point A to point B. The direction of the force goes from A to B. We are required to find the rectangular components of this force in the space. So how do we proceed with this? We define the position vector from A to B. Once we have the position vector, we find the unit vector in that direction. That will be a vector with magnitude 1 in the direction of the force, meaning from point A to point B. So in order to find the rectangular components of the force F, we just have to multiply the magnitude of the force times the direction. So let's see how that works. Let's draw the position vector here as this line. Let's say this is point B here, and this is the vector position vector RAB. Let's say coordinates of point A are XA, YA, CA. Coordinates of point B are XB, YB, CB. So as we saw before, the position vector then is given by the subtraction of the coordinates of the points. In this case will be point B minus point A. So this comes to be XB minus XAI plus YB minus YAJ plus CB minus CAK. In order to find the unit vector in the direction of the position vector, we have to divide this vector by its magnitude. So we need to find the magnitude. The magnitude of vector AB, as you probably know already very well, is a square root of the components. Square square. So now we have the magnitude of the position vector. The unit vector in the direction of the position vector, which is in the direction of RAB, let me put it here like green. So it will be a vector in this direction. It will be a vector U, magnitude 1. Then that will be given by dividing the vector RAB by the magnitude of the vector RAB. This is magnitude 1, and then this is the vector that defines the direction of the force. So in order to find the force in its rectangular components, we just have to multiply the magnitude of the force, which was given, times u. So if we expand this expression, we have the rectangular components of the force F. If we are required to have the direction of the force as the angles that this force makes with respect to the three axes x, y, and z, then we just find the cosines of the coordinate angles, alpha, beta, and gamma, and then with the cosines we get the angles. So, and the cosines are given by the each one of the components of the vector divided by the magnitude. So then those cosines will be cosine alpha equal to xb minus xa over the magnitude of rab. Cosine of beta will be yb minus ya divided by the magnitude of AB, and cosine of gamma will be CB minus CA divided by the magnitude of the vector, of the position vector. So this is better seen with an example. So let's take a look at an example. We have this frame ABC is supported in part by cable DBE, cable DBE that passes through a frictionless ring at B, knowing that the tension in the cable is 385. Tension is 385 newtons. Determine the components of the force exerted by the cable on the support at D. So the cable is pulling the support at D in this direction. So this is our force T. So is a force that it goes in the direction from D to B. So we have to find the position vector dB. So what we need to do is basically here find the coordinates of point B and subtract the coordinates of point B. The coordinates of point B are in the x direction. In the x, this is the x-axis. So in the x direction, this is the x coordinate of point B, 480 millimeters. In the y direction, this point B is on the plane CX, so there is no component in the y direction. And in the z direction, the z direction is this axis here, so the coordinate on the z direction is 600 millimeters. Now for point D, the coordinates are point D is on the plane YZ, so it doesn't have x coordinates, so we have 0 here. Then for the y axis, the coordinate is 510 millimeters, and for the z is this 280 millimeters. So now we do the subtraction of the coordinates. Let's do it here. So 480 minus 0 will be this 480 minus 0. This will be 0 minus 510. And this one will be 600 minus 280. So we have here 480 minus 510 and 320. Those are the components of the position vector. Let's write it here. Position vector R D B then comes to be 480 millimeters I minus 510 millimeters J plus 320 millimeters K. It has the units of millimeter. Is basically a vector that has a length of the distance from D to B. So now we need to get the unit vector in the direction of the direction of RDB. In order to get the unit vector, we have to divide RDB by its magnitude. So we need to calculate the magnitude of RDB. RDB magnitude will be the square root of 480 square plus minus 500 square plus 320 square. That comes to be 770 millimeters. Now we can express our u. Let's do it in one shot. So now we're gonna express here our vector t, our 4t, as the magnitude times the unit vector, where the magnitude is 385 newtons, and the unit vector is the RDB, 480 millimeters I minus 510 millimeters J plus 320 millimeters K divided by the magnitude of 770 millimeters. All these millimeters go away and we have units of newtons. So we end up with T equals to so 385 times 480 times 770. 385 times 480 divided by 770 equals 240. 240 newtons I minus 510 times 385 divided by 770, 255 newtons J plus 320 times 385 divided by 770, 160. Okay. So if we want to be very specific about the components that we will do, so Tx will be 240 newtons I, Ty will be minus 255 newtons J, and Tz will be 160 newtons K. Let's find the angles alpha, beta, and gamma now based on the direction cosines, and let's verify those cosines. The square of those cosines add up to 0 to 1. That will be a nice check. So cosine of alpha is equal to 480 divided by 770 equals to, we'll do that real quick here, 480 divided by 770, 0.623338 cosine of beta equals minus 500 divided by 770 equals to 500, I said 510. So this is a mistake here. This is actually 510. 510. So we have 510 divided by 770 minus 0.66233662334 and cosine of gamma equals to 320 divided by 770 equals 320 divided by 770 equals 0.41558. Will be a good check to verify if we add the square of these cosines, we get a 1. So if we take summation of these cosines square, we should get a 1. Let's do it really quickly. If I have 0.41558 square plus 0.66234 square plus 0.62338 square equals 1.000007306. 1.0000007. So good. It's a good thing to do that check just to verify you didn't make an error somewhere. The summation of the squares of the cosines have to be equal to 1. Now, if we want to get the angles, we just get the arc sine of those values. Alpha will be the arc cosine of 62338, 51.4 degrees. Beta will be arc cosine of minus 0.66234 equals 131 degrees. Be very careful with the minus sign here, okay? Cosine minus 1 of 0.41558, 65.4 degrees. So this would be the answer here. The components of the force, rectangular components of the force on the direction angles of the force. All right, that's it.